Welcome to Chapter 2, Describing the Distributions of Variables, of a variable. Introduction. Our goal is to present data in a form that makes sense to people. Tools that are used to do this include graphs, bar charts, pie charts, histograms, scatter charts, and time series graph. Numerical summary measures, counts, percentages, averages, and measures of variability. Tables of summary measure, totals, averages, counts, groups, and by category. Introduction. There are 4 steps in data analysis. Recognize a problem that needs to be solved, gather data to help understand and then solve the problem, analyze the data using the tools you will learn. The analysis can sometimes repeat steps. Act on this analysis by changing policy, undertaking initiative, published reports, and so on. Basic concepts. Several important concepts we'll go over: populations and samples, data sets, variables and observations, and types of data. Populations and samples. A population includes all the entities of interest in a study: people, household, machines, etc. Examples: all potential voters in a presidential election, all subscribers to cable television, all invoices submitted for Medicare reimbursement by nursing homes. A sample is a subset of the population, often randomly chosen and preferred representative of the population of whole. Data sets, variables, and observations. A data set is usually a rectangular array of data with variables in columns and observations in rows. A variable or field or attribute is a characteristic of members of populations such as height, gender, or salary. An observation or a case or a record is a list of all variables for a single member of the population. Data from an environmental study. Objective: to illustrate variables and observations in the data. Solution: data sets include observations of 30 people who responded to a questionnaire on the president's environment policies. Variables include age, gender, state, children, salary, and opinion. Included in the row, list of variable names. Included in the columns are the results. Observation. Data types. A variable is numeric if meaningful arithmetic can be performed. Otherwise, the variable is categorical. There is a third type of data, date. The variable Excel stores dates as numbers, but the dates can be treated differently from numeric thing. Category, variable, or ordinal if there is a natural order of its possible value. If there is no natural ordering, it is nominal. Data types. Variables can be coded numerically. A dummy variable is a 0 or 1 coded variable with a specific category. It's coded as 1 for all observations at category and 0 for all observations that is not. A bin variable corresponds to a numeric variable that has been categorized in discrete categories. The categories are usually called bins. This is just an example of bins. Here we have over here the bins. Young is 0, middle-aged is 30, elderly is 6, and so you can kind of see in gender if it's a 1, strongly disagree. So you can kind of see a little bit of 1 and zeros, and allows you to see what's going on. A numerical value is discrete if it results from a count, such as a number of children. A continuous variable is a result of essentially continuous measurements, such as height or weight. Cross-sectional data of a cross-section of a population at a distinct point in time. Time series data is data collected over time. And you can see this is first quarter, second quarter of 2015, up to 2018, the different revenues. Summary of categorical variables. There There are only a few possibles for describing a category variable, all based on counting. Count the number of categories, give the category's name, count the number of observations. The resulting counts can be reported as raw counts or a percentage of total. Once you have the counts, you can display them graphically using the column chart and pie chart. Supermarket sales data, another example of data to summarize categorical variables in large data sets. Solution. Dataset contains transactions made by supermarket customers over a 2-year period. Children, units sold, purchase date, transactional and customers are used. All the variables categorical. Supermarket sales. To count in the column S, use the Excel function COUNTIF. To get the percentage in column T, divide each count by the total number of observations. Keep the chart simple, easy to read and follow. Another efficient way to count for a category variable is to use dummy variables. Recode each variable so that the category is replaced by a 1 and a 0. This can be done using the simple if formula. Find the count, the category 1 and 0. If the percentage is that, change it. Summarizing numeric variables. There are many ways to summarize numeric variables, both with numeric summary measurements and charts. We begin with a numeric variable such as salary, where there is one observation for each person. Our basic goal is to learn how these salaries are distributed across people by asking, what are the most typical salaries? How spread out are the salaries? What are the extreme salaries on either end? Is a chart of the salary symmetric about some middle value, or is it skewed in one direction? Does the chart of salaries have any other particular features besides possible skewness? Numeric variables, summary measures. Throughout this section, we focus on salary variables. Measures of central tendency, min, max, percentiles, and quartiles. Measures of variability, empirical rules for interpreting standard deviation. Measure of shape, numeric summary measures in the status bar. Examples of baseball salaries. Objective, to learn how salaries are distributed across all 2018 Major League Baseball players. Solution, dataset contains 877 Major Baseball players for 2018 season. Variables are player's name, team, position, and salary. Measure of central tendency. The mean is the average of the values. If the data set represents a sample from some larger population, this measure is called a sample mean and denoted by. If the data set represents the entire population, it is the population mean and represented by the formula. In Excel, the mean can be calculated with the average function. Measure of central tendency. The median is the middle observation when the data are sorted from smallest to largest. If the number of observation is odd, the median is literally the middle observation. If the number is even, the median is usually defined as the average of the two middle observations. In Excel, the median can be calculated with the median function. The mode is the value that appears most often. In most cases where a variable is essentially continuous, the mode is not very interesting because it is often the result of a few lucky tries. However, it is not always a result of luck and may reveal interesting information. In Excel, the mode can be calculated with the mode function. And over here, you can kind of, up in the top left, you have mean, median, and mode. You can see the difference between them, but it allows us to have what's going on. And it each tells us a little bit different information. Minimum, maximum percentiles and quartiles. For any percentage P, the percentile is the value such as the percentage of P of all values are less than it. The quartile divided the data into 4 groups, each with approximately a quarter of all observation. The first, second, and third quartiles are that. The minimum and maximum values can be calculated with the min and max functions and the percentiles, quartiles, percentile, and quartile functions within Excel. Variability, the range is the maximum value minus the minimum value. The interquartile range is the third quartile minus the first quartile. This is the range of the middle 50% of the data. If this sensitive is extreme values, then the range. The variance is the approximability, the average of the square deviation or the means. If xi is typical observed, it is squared deviation from the mean. The sample variance is denoted by S, and the population is by sigma squared. S squared, sigma squared. And all observations are close to the mean. They're squared deviations from the mean, and the variance will be relatively small. If at least a few of the observations are far from the mean, there are squared deviations from the mean, and the variance will be large. In Excel, use the var.s function to obtain the sample variance, and the variance.p for the population variance. A fundamental problem with the variance is that it is squared. Example, $ squared. A more natural measure is the standard deviation, which is the square root of the variance. A sample deviation is denoted by S is the square root of a sample variance. The population standard deviation is by sigma and the square root of that. In Excel, use the standard deviation S function to find the standard deviation, or the standard deviation P function to find the population. And as over here, you can kind of see the difference of what's going on with the data, the standard deviations, the population versus a sample down at the bottom here. You can have the sample variance and population. It just depends on what we're doing. And the reason you want to measure that is so you can understand if it's a sample, it's only a sample. If it's all the data, it's actually more accurate. Empirical rules for interpreting standard deviation. The interpretation of standard deviation can be stated in 3 empirical rules. Empirical means that they are based on common observed data as opposed to theoretically mathematical arguments. If the value of the variable are approximated, normally distributed, symmetric, and bell-shaped, then the following holds true. About 68% of the observation within one standard deviation, approximately 95% of the within 2 standard deviation, and approximately 99.7% of the observations are within standard deviations and means. The empirical rule for interpreting standard deviation. The empirical rule should be applied with caution, especially when the data is clearly skewed, as illustrated in the baseball salaries. The mean absolute deviation is the average of the absolute deviation. In Excel, use the AVE-DEV function to calculate the mean absolute deviation. There is another empirical rule for MAD for many variables. The standard deviation approximately 25 larger than mean absolute deviation. Shape, important part of when reviewing data. Skewness occurs when there is a lack of symmetry. A variable can be skewed to the right or positive because some of the really large values, baseball salaries is an example, or it can be skewed to the left, or negatively skewed because some really small values, temperatures in the Antarctic. And Excel measures skewness with the function skew. Kurtosis has to do with the fatness of the tails of the distribution relative to the tails of the normal distribution. A distribution with high kurtosis has many more extreme observation. In Excel, kurtosis can be used with Kurt function. Numeric summary measures in status bar. If you select multiple cells, summary measures appear to be selected cells. In the status bar at the bottom of the thing, you can choose the summary measures that appear right of the status bar. Numeric summary measures, the add-in. Although built-in functions in Excel can be used to calculate a number of summaries, measures such as quicker way to use stat add-in. StatTool is part of the Palisades Decision Tool Suite. Once the suite is installed, load StatTools by double-clicking the stat. You will know that stat tool is loaded when you see the stat tool in the tab ribbon. Charts and numeric values. There are many graphical ways to indicate the distribution of numeric values. For cross-sectional histograms, box plot, also known as box and whisker, and for time series graphs. A histogram is the most common type of chart showing distribution for numeric values. It's based on binning the variables, that is, dividing it up into discrete categories. It is a column chart with the count in the various categories with no gaps between the vertical thing. A histogram is great for showing the shape of the distribution, whether the distribution is symmetric, skewed in one direction. Histograms of salaries. You can see the skewness. It is not a typical histogram. Box plots, or box and whisker, is an alternate type of chart for showing the distribution of variables. Side-by-side box plots are very useful for comparing distribution. Box plots and histograms are complementary ways of displaying the distribution of numeric variables. As with histograms, box plots are big picture charts. Show the distribution of the variables. So you can see here in this useful chart, most of the data is below 5,000 or 6,000. As the data moves up, it is harder to see what's going on, the salaries. Very few people make that much. Box chart consists of minimum amount of values, first quarter, the median, the third quarter, and the maximum. Outliers may be shown as individual points. Time series. One of the main interest in time series variables is how they change over time, and this information is lost in traditional summary measures and in histograms and box plots. For time series data, a time series graph is used. This graph is of the values of one or more time series used. This is always a place to start your time series analysis. And you can see here from 1960, you go through all the different dates. Crime in the U.S. Objective: to see how time series graphs help to detect trends in crime. Solution: data set contains annual data on violent and property crimes between 1960 and 2010, and stat tools designated a stat data set. Then select time series graphs for the time series and forecasting drop list and filled in the resulting dialog box. So you can see over time how things have changed. Violent crime, as you can see, it's gone down. And again, this is just reviewing the data. This one's actually looking at the rates of violent crime, peaking in the early 90s and now dropping down. And again, just property crime. As you can see the time series, how it changes, and gives us a good picture. Dow Jones Index. Define useful ways to summarize a monthly Dow Jones. Data set contains monthly values of the Dow from 1950 to 2016. And as you can see, over the years from 1950 to 1994, it was below 5,000. And it wasn't until 95, that's the release of the internet, when the internet became popular, and then you can see how companies have changed by utilizing the growth of that. Dow Jones Index, again, looking at it over the spread of what's going on with the deviation. Outliers and missing values. An outlier is a value or an entire observation that lies well outside the norm. Some statisticians define an outlier as any value more than 3 standard deviations from the mean. This is only a rule of thumb. Even if the values are not unusual by themselves, there still might be unusual combinations of the value. When dealing with outliers, it is best to run analysis 2 ways, with outliers and without outliers. Missing values. Most real data sets have gaps in the data. They are missing 2 missing issues: how to detect these missing values and what do we do about them. The more important issue is what do we do about them. One option is simply ignore them. Then you will have to be aware that the software deals with missing values. Another option is fill in the missing values with the average of the non-missing values, but this isn't usually a very good option. The third option is explain Examine the non-missing values in a row and missing values. These values might provide clues on what missing values should be. Tables, filtering and sorting tables and tools are introduced in Excel 2007. You have the ability to designate a rectangular data set as a table that employ a number of powerful tools for analyzing data. These tools include filtering, sorting, summarizing. The high-text customer data. To illustrate tables in Excel using high-text data, data sets contain about 1,000 customers of high-tech fictional direct marketing. Designate the data set as a table. Select any cell of the data, clicking on the table. Use the drop-down arrows to filter out data. And as you can see, we can play with that. Excel is extremely powerful. Filtering records the data match particular criteria is called filtering. One way to filter is to create an Excel table, which automatically provides drop-down arrows next to the field's names that allow you to filter. There are 3 ways to filter any rectangular data set with a variable's name. Use the filter button and sort the filter drop-down list on the home ribbon. Use the filter button and sort the filter group on the data ribbon. Or right-click on any cell in the data set and select filter. You can have several different options. Filter by selected cell. High-text customer data. Investigate the type of filters that can be used. Applied in high-text data. Solution: there's almost no limit to the filters you can apply, but there are a few possibilities. Filter on one or more of the values. Filter on one or more field. Filter on a continuous numeric value. Top 10 filter, above or below average. Filter on text, filter on date, filter on color. Use custom filters. And these are all the options of filters that you have using high-tech data. Again, we can customize what we're looking for. Thank you. Chapter 2.